Earth's magnetic field may seem unchanging to us humans going about our daily lives, but the truth is not only is Earth's magnetic field constantly in a state of flux, pun intended, but the changes are actually big enough to have observable effects on and around our planet. Earth's magnetic field is generated by electric currents in a swirling layer of nickel and iron in the Earth's molten outer core. The field extends out into space and protects us from the worst of the sun's solar wind, a stream of energetic charged particles that would otherwise quickly strip the ozone layer from our atmosphere and expose us to the full intensity of the sun's ultraviolet radiation. For example, many scientists think this is what happened to the atmosphere on Mars. In addition, satellites in orbit and even some large ground-based computing facilities can be subject to damage from ionizing solar radiation, and a detailed understanding of Earth's magnetic field is crucial in helping to mitigate these effects. In a new paper, scientists have used 11 years of data from ESA's SWARM mission to investigate anomalies in Earth's magnetic field. SWARM is a constellation of three identical Earth-observing satellites that record a three-dimensional map of the magnetic field around the Earth. The scientists were particularly interested in a region called the South Atlantic Anomaly, an area where the magnetic field is known to be weak. In the animation behind me, you can see how more events were recorded by SWARM in the area of the anomaly than in other places. Although I want to note this graphic is from some different research done in 2020, but it is still SWARM data. The area of weak field can mean that satellites are exposed to more radiation while passing through. The research has found that the South Atlantic anomaly has been slowly growing in size from 2014 to 2025, but it is also not changing equally in all directions. The team believes these changes are due to the effects at the boundary between the rocky mantle and the molten core of the Earth in this region. There are also two areas of particularly strong magnetic field, one over Canada and the other over Siberia. The satellite data show the field over Siberia has grown in size over the last 11 years, while that over Canada has shrunk. The reasons for this are complicated, but are related to turbulence in the Earth's core that causes the Earth's magnetic pole to drift over time. We know that a compass is a useful navigation aid, but we also know that corrections need to be applied to convert from the magnetic north of the compass to true north on the surface of the Earth. Those corrections gradually change over time, and that drift is what we're seeing with the growing size of the strong field in Siberia. It's awesome to see these results from SWARM, and it's pretty crazy to think that our continued existence on this pale blue dot is dependent on so many different systems all working together. That's today's video. Don't forget to drop a like. I'll catch you in the next one.